Hello students, this is Shailaja Vibhute. Let us continue units and measurements. Today let us learn about accuracy. So what is this accuracy? Usually accuracy is used for measuring instruments. Means the accuracy of a measurement is a measure of how close the measured value is to the true value of the quantity. Or you can take one more definition, that is the closeness of a measurement to the true value is called accuracy. What is meaning of this one? Let us try to understand. Let us take one example. Say you have drawn one line. Okay, say line is drawn. And when it is measured, say its measurement is say 1.25 meter. Okay, then this is true value 1.25. Now what we will do, we will ask one student to measure it. Okay, so when he measured, his value is say it is 1.23 meter. Okay, now let us call one more. Then according to another student, when he measured, then it's found to be 1.24. So just observe these values. 1.23 is first measurement, second measurement is 1.24. So these are measured values. Okay, then what about this 1.25 now? This 1.25 is true value. So these two are how much close to this 1.25? If these are close, then accuracy is high. Okay, now observe it, definitely 1.23 and 1.24 both are close to this 1.25. Then accuracy is high. Okay, so what is accuracy then? The closeness of a measurement to the true value. So how close the measured value is to the true value, then it is called accuracy. Say if it is measured by one more student and if he measured it as say 0.9, 0.9 and 1.25, much difference is there, correct? So definitely this value is not at all accurate compared to, means it is not near to true value. So accuracy is very low, correct? But in these two measurements, definitely these are close to 1.25, so accuracy is high. You are understanding? Okay, so what is accuracy? What you have to remember now? You are measuring the quantity when it is measured by taking number of measurements. Just observe the values. If measured values are near to the actual value or true value, definitely you are more accurate, or your measurement is more accurate. Clear? Okay. Now let us go for one more word, that is precision. Actually, when we deal with measuring instruments, these two terms are very important for us. One is accuracy, another one is precision. So now let us try to understand what is this precision. Precision tells us to what resolution or limit the quantity is measured. I hope you have heard the word like resolution. Usually resolution is for measuring instruments. So resolution is very high, especially for telescope. If resolution is high, you can see the objects very clearly, correct? So precision can be defined in another way. It is how close the measured values are to each other. Not to the actual value, each other. Okay, say you have measured number of times, all those number of measurements are how much close to each other, that we have to see. To understand, let me take one more example here. One more example means previous example only you can take. 1.25, it is a actual measurement, true measurement. Near values are 1.23 and 1.24, right? So 1.23 and 1.24 are very near to, very close to one another. Definitely precision is high then, correct? So to get the clear idea about accuracy and precision, now I will take one example. Okay, so let us take this example now. In this example, this red color center one, what you are observing now, this one, let us suppose it is true value. Okay, then arrows what you are seeing now, these are measured values. Okay, so red color center one is actual value and the arrows are measured values. Now take the first one, first diagram. Red color, it is center one is actual value and the arrows are very close to one another. So if these are very close to one another, what is our conclusion? Precision is high. Because what is precision? How close the measured values are to each other. So arrows are very close to each other, definitely precision is high. What about accuracy now? To find the accuracy, these measured values are definitely exactly on the red color. So red color is actual value. So how the measured values are, how much close to the actual value? Almost same. Definitely accuracy is also high. So in the first figure, measured values are very close to one another. So precision is high. And these measured values are also close to actual value, definitely accuracy is also high. Clear? Okay, now take second one. So center one is actual value and these are measured values. Just observe the figure now. Measured values, arrows are very close to one another. So measured values are close to each other, means what? High precision. Correct. Whether these are close to the center? No. These are little far from the measured, means actual value. Correct. So measured values are little far from actual value. Definitely accuracy is low. Okay. Accuracy is low, but it is high precision. Clear? Now see the last figure. This is actual measurement and these are actual value and these are measured values. So arrows are, first point, arrows are little far from one another, not close to each other. Correct? So what about the precision? Low precision. And no doubt arrows are not close to the true value. So even accuracy is low. So in the third figure, it is low precision, low accuracy. I hope you are understanding the difference between precision and accuracy. So here in the second figure, precision is high because arrows are close to each other, but they are not close to, not near to true value. So low accuracy but high precision. In the first figure, all the measured values are close to each other, high precision, and close to the actual value, so high accuracy. Hope you understood the difference between accuracy and precision. Fine. Now let us try to understand the meaning of error. Very simple word, very easy word. Error is nothing but, according to our language, it is mistake. Correct? When we measure a quantity, if there is a difference between true value and measured value, then it is called error. Correct? So the uncertainty in every measurement is called error, or it is the difference between the measured and true values of a physical quantity. It is the difference between measured value and true value. Okay? So if you take difference between measured value and true value, it is nothing but error. Now let us take types of error. So what are the types of error? There are mainly two types. One is systematic error, another one is random error. See the word systematic error means what? You are doing mistake systematically, correct? So now let us see what is the meaning of systematic error. Means which error we can call it as systematic error. Systematic error is nothing but these errors tend to shift the result in one direction. Means when we see the causes for systematic error, why this error we will get, then definitely we will understand what is the meaning of systematic error. So first cause for this systematic error is instrumental errors. Instrumental errors means what? Now let me take one very simple example. You take example of your scale only. Okay, you take example of meter scale. Meter scale you are familiar. Okay, when you purchase a new scale, just observe the edges. Edges will be very sharp, correct? Then when we measure, perfect measurement we will get. But say you have taken such a scale which is or means like this. Okay, for such scale, say your measurements will start from here only. Then if you measure using such scale, definitely all the measurements will be, definitely you will get some mistake in your measurement, some error in your measurement, at least one small line, correct? So you are doing the mistake even though you know the instrument is, measuring instrument is not proper and you are measuring, definitely it is systematic error. Okay, now let us take second reason, that is imperfection in experimental technique or procedure. Imperfection in experimental technique or procedure means what? When you are measuring, means with the help of a measuring instrument, if you are measuring a quantity, you should know the proper method of using the instrument, correct? You should know the procedure how to do the experiment. Let me take one simple example. Say you are measuring body temperature with the help of thermometer. So while measuring the body temperature, thermometer must be placed under the armpit, or you can take the thermometer and you can keep in your mouth so that you can see the temperature, correct? Usually difference will be there in between these two. One is, say, thermometer, if it is placed under the armpit, always it shows a little less value compared to the another method. Even though we know it, if we follow the procedure, that is placing the thermometer under the armpit, definitely some error will be there in our measurement. It is called imperfection in experimental technique. Okay, now third cause is personal error. Personal error is very simple. Say when I measure the quantity with the help of measuring instrument, again I had to follow the proper method. Say reading a thermometer from below the horizontal line of sight. When you see the thermometer, you can see the lines there. Okay, little you have to hold the thermometer in a proper method and you have to see the temperature. But when you see a little side by that thermometer, definitely measurements will be, definitely you will make some mistake in your measurement. That is called personal error. Okay, now let us go for second type, that is random error. Random error, these are irregular errors with respect to size and sign. No consistent effects across the entire sample. Means what? What is meaning of this random error? Let us take one example. You are doing the experiment in a lab with the help of electricity. Okay, then usually in electricity, voltage fluctuations will be there. Suddenly you will get voltage fluctuations and you will get error in your measurement. So that is example for random error. Unexpected fluctuations due to fluctuations in voltage supply. That is example for random error. Okay, so what are the types of errors? You can expect the question for 2 marks. Only you have to mention the name there. One is systematic error, another one is random error. Only to understand, I have explained the causes for systematic error. Okay, but in exam usually we expect the question types of errors. Only you have to mention the types. Now let us see very interesting word, that is least count. So what is least count? It is the smallest value an instrument can measure. What is meaning of this one? Let me take example of our scale only. What is the smallest value that can be measured with the help of our scale? Our scale, let me take like this, say 0, correct? Then one small line, then one big line, small line, big line, small line, big line. Like this you will get 10 lines, correct? 1, 2, 3, 4, 5, 6, like this it continues. Then if I ask what is the value of this smallest line? Yes, 1 millimeter, correct? This is 1 millimeter. Okay, so this is the smallest value that can be measured with the help of our scale. Then what is the least count of our scale then? 1 millimeter. Okay, so 1 millimeter is the least count of our scale. So what is least count then? The smallest value an instrument can measure. Say you are measuring with the help of a clock. In the clock, if you see, say first is 0, then after that in seconds if we are getting 1, 2, 3, 4, 5 like this, this is 1 second. If it is 1 second, then the smallest value of that clock is least count, and that least count will be 1 second. Clear? Okay. Then let us go for next point. Say we want to measure the error now. We want to calculate the error. So to calculate the error, some words we should be familiar with some words here. Let us see those words one by one. First one, absolute error. So what is this absolute error? Difference between individual measurement and true value of the quantity. What is meaning of individual measurement here? Just now I said, to get the accuracy in a measuring instrument, usually we used to take number of measurements. Number of measurements means what? Say measuring the length of a line number of times. Say measuring the time number of times. That is called number of measurements. Now take the difference between each measurement with the true value. Individual measurement and true value. Then you will get absolute error. This absolute error usually it is denoted by mod delta A. So this is called mod. Two lines, parallel lines you will draw now, it is called mod. If you are writing the value in mod, then it is nothing but you are taking only positive values. So always it is positive. Means after subtraction, if you are getting minus sign, you have to neglect it. That is the meaning of mod delta A. Delta is for difference. Okay. Now here one example I have written. Say you have measured a quantity 10 times. Means 10 readings you have taken. In that you want to find out the absolute error. So how to find absolute error? Delta A1. A1 is for first value. Delta A1 is equal to A1 minus A mean. What is this A mean now? This A mean is nothing but it is true value. So true value, how to calculate? Average of all the values. Say for example, you have taken the time, measurement of time 5 times. One value is 2 seconds, another value is 3 seconds, another value is 1 second, then next one is say 4 seconds, then again one it is 2 seconds. Like this you have taken 5 readings. Then out of these 5 readings, you want to find out true value. So how to find true value? Take average of all these, means add it. 4 plus 1 plus 3 plus 2 plus 2 divided by number of values. How many values are here? 5 values are there. Divided by 5, you will get mean value. That mean value will act as true value. Okay, so that is A mean. First value how to calculate? Delta A1 is equal to A1 minus A mean. Similarly, you want to calculate second one. Delta A2 is equal to A2 minus A mean. Delta A3 is equal to A3 minus A mean. Like this you have to continue. Clear? Okay. Now let us see another one, that is relative error. So what is this relative error? It is the ratio of mean absolute error to mean value of a quantity measured. Means what? It is delta A mean. Delta A mean means how you will calculate absolute error. Based on these all you have to, how much you will get for each value, you have to add all those divided by number of times, so that you will get delta A mean. Divided by A mean, you will get relative error. Okay. We will take one example to solve the problem so that you can understand. Then next one is percentage error. So how to calculate percentage error? Relative error, you multiply it with 100, you will get percentage error. To understand these absolute error, relative error and percentage error, let us take one example. In successive measurements of time period of oscillation of a pendulum, the readings turn out to be 2.63 seconds. So what is pendulum? Let me show first. So you have to take one support, take a thread, then take one metal bob. Okay. So metal sphere, you can say metal sphere, suspend it, it acts as pendulum. Now allow it to oscillate, like this it will oscillate. Okay. So you have to find out the time. So in successive measurements of time period of oscillation of pendulum, the readings turn out to be 2.63, 2.56, 2.42, 2.71 and 2.80. Calculate absolute errors, relative error and percentage error. So to calculate absolute error, first we have to calculate mean value. How to calculate mean value? To calculate mean value, you have to add all these values, correct? One is 2.63 plus 2.56, 2.42 plus 2.71 plus 2.80, correct? Mean value you have to calculate. How many values are there? 1, 2, 3, 4, 5. So divided by 5 you have to do. So when you will do divided by 5, you will get mean value, right? So mean value when it is calculated, you will get 2.62. So A mean we have calculated. Now you have to calculate absolute error. So to calculate absolute error, what you have to do? A1 minus A mean you have to take. What is first value? 2.63. 2.63 is first value. Mean value is 2.62. Subtract it. You will take 0. You will get 0.01. Okay. Then next one is A2. A2 minus A mean. 2.56 minus 2.62, you will get 0.06. I hope you are observing negative sign is neglected because it is mod. Then A3, similarly you will get 0.20, means third value. Similarly fourth value 0.09. Then for fifth value 2.80 minus 2.62 is 0.18. Then you have to calculate relative error. So how to calculate relative error? Delta A mean divided by A mean. So delta A mean how to calculate? You have to take mean of these values. Okay. Mean of these values how to calculate? Add all these divided by 5 you have to take. Add all these 5 divided by 5. How much you will get? 0.11 you will get. So delta A mean how much you got? 0.11. A mean already we have calculated, it is 2.62. Clear? So when you divide it, you will get the relative error as 0.04. So when you divide 0.11 divided by 2.62, you will get 0.04. It is relative error. Clear? Then multiply this value with 100, you will get percentage error. So 0.04 into 100 is 4%. So it is percentage error. So first what we have to do? Take all the values, add it, divided by number of readings, you will get A mean. Okay. After getting A mean, it becomes our true value. Individual value minus true value gives absolute error. So this is for first reading, then second reading, third reading, fourth reading and fifth value. After getting these values, add all these divided by number of readings. 5 readings are here. So divided by 5, you will get delta A mean. So delta A mean divided by A mean gives relative error. Then relative error into 100 gives percentage error. Clear? Very simple one. Try to take yourself a number of values for any measurement and try to solve the problem so that you can understand it clearly. Hope you understood. In the next class we will go for combination of errors. Thank you.